Hello everyone, today we present and demonstrate to you two autonomous robots that we designed and optimized in 8 weeks. These robots simulate exactly as real-time robots on planet Venus, which completely autonomously collect rock samples and bring them back to a laboratory. Since a real robot faces a great deal of obstacles on a completely different planet, our robot is also ready to take on any real-time challenges and obstacles, such as mountains and craters. The robot will be exploring a certain bounded given area for rocks, starting from the lab base camp. Now, we'll be glad to show you what the robots do and give you a brief idea of how they work. Stay tuned. Starting from the basics, these robots work on the Arduino Uno and XP platform. The robots consist of 3 motors each. One motor to power the wheels, one to operate the ultrasound sensors that detect the obstacles, and a third one to move the grippers that hold and drop the rocks. This is not the most interesting part. The most interesting part is how they detect and sense objects and locations, and simultaneously communicate with each other. Essentially, the robot has to detect the rocks, its destination, its location, and in some cases, the other robot in order to avoid interference or collisions. All this helps the robot to effectively accomplish their primary mission objective: collect as many rocks as possible and bring them back safely to the laboratory. Take a look at the video coming up next to experience the real-life action. Now, on the journey to explore the planet, there will be obstacles all around that the robot has to navigate through. Mountains and craters will be all over the place, making the expedition problematic, but we designed a robot to take any challenge thrown at it. The two big eyes that you see right on top front of the robots are ultrasonic sensors. They detect the upcoming mountains and craters, after which the code commands the robot to stop. After a stop, the ultrasonic sensor rotates 90 degrees in both directions to detect the obstacle-free route. To give you a simple idea of how that works, those ultrasonic sensors emit a short high-frequency sound pulses at regular intervals. These propagate in the air at the velocity of sound. If they strike an object, then they reflect back to the echo signals to the sensor, which itself computes the distance to the target based on the time span between emitting the signal and receiving the echo. Now, as you can see, the area the robot explores is bounded by some black tape. The robot is not allowed to go outside that area. As soon as the robots reach the borderline, they change their direction. They detect the black tape with the help of the 2 digital encoders on the metal platform that you see right in front of the wheels. These little encoders also help the robot to detect if there is no more land in the direction it's going. This helps if the robot is on a high platform, so that it does not fall down. Even the craters are represented by the black tape of the terrain. We have placed the encoders as close to the ground as possible since they have a very short range. The most fascinating part of what the robot does is the detection and picking up of the rocks. The rocks you see in the video are made up of a surface that reflects infrared. This is different from the mountain obstacles, which absorb infrared beams. The rocks, on the other hand, will be reflecting the infrared signals, giving the robot the signal to pick up the rock. The robot is programmed such that as soon as it receives the signal, it heads towards the rock to pick it up. The infrared sensors are placed exactly in front of the gripper on the robot front, using a long wire-made platform. Another interesting fact is the robot is hard programmed such that as soon as it is able to pick up the rock, the sensor platform attached to the servos changes its direction in order to prevent hindrance to the gripper picking up the rock. Our idea behind placing the sensor at a great distance away is because of the short range of the sensor. We have paid quite a lot of attention to the fact that only one robot will be able to enter the laboratory. To make this possible, we set up some communication between the robots, just that they both know whether the other one is on the laboratory or not. For this we use the XP radio frequency devices that you see, which are placed above the Arduino Uno board. We have also modified the laboratory in order to make it easier for the robots to detect it. There is only one point of access to the laboratory out of 4 sides, so the modifications were made such that when the robot is in the vicinity of the laboratory, a path guiding it towards a specific entry point is made, so the rock is dropped at the right place. This accomplishes our exploration mission on Venus. We hope you found our video demonstration and exploration interesting and useful. Thank you for watching.